I'm Chris Newell. I work for BBC Research and Development. I'll just give you a quick introduction to the department. The BBC's charter actually requires us to do research and development, not just for the BBC, but for the whole UK media industry. We've got about 200 staff working in 2 research labs, one in London and one up in Salford. And we work on every aspect of broadcast and online services. So that's from the content production through to the distribution and then the consumption by audiences and any interaction with the audiences. We've got a small team who works on natural language processing. So as well as semantic tagging and text classification, we do a lot of work on speech to text and things like text summarization and sentiment analysis. And we apply these techniques to the large volume of text that the BBC deals with in its day-to-day activities. So all the web pages, a lot of news feeds, but also the subtitles and transcripts associated with all our programming, which is a vast amount of text data. Then we also look at social media, either the BBC's internal forums, public forums, and external social media sites. So today I'm going to focus on semantic tagging and text classification. And in summary, this is describing a document in terms of unambiguous entities and themes, and using those to link to additional sources of information. And the tagging can either be all the entities and themes mentioned in the text, and we call this mentions tagging, or it can be the primary topics of the text, so just 2, 3, 4, maybe 5 topics, and we call this about tagging inside the BBC. The motivation for this work goes back 10 years to a project called the World Service Archive Project. And this project basically took and digitized a large number of programs, 70,000 from over 60 years of broadcasting on the World Service. And unfortunately, the metadata associated with that content was very sparse, quite often inaccurate or even non-existent. Quite often there was just a box with the tape in it, with a handwritten note stuck to it. It was really very difficult to see what we had there, but obviously there was going to be some real gems. And so what we needed was a way to find out what was in there and be able to search and navigate and so forth. An efficient use of this is impossible unless you have good metadata, so that's what we needed. So the approach we adopted was to run all that content, and I think it was something like 3 years of continuous audio, through speech-to-text technology to create transcripts for all the programs. And then we developed an automated tagging system called Mango to extract tags from that text. And then we use those tags to support search and navigation in the prototype, which you can see on the right. And whilst that prototype was publicly available, we actually allowed people to give feedback on the tags so they could correct errors or correct omissions. And we found there were quite a few people who were keen to do this, took it quite seriously, and obviously some domain experts out there who are keen to tag programs they were interested in. Now, Mango, the system we developed for this, is basically a semantic tagging system, and it identifies mentions, anything which is mentioned in the text. So for the text you can see here, we really want to identify these key entities. And to identify them, we use something called DBpedia identifiers. DBpedia is a database which is basically derived from Wikipedia, and you can probably recognize from the last part of these locators that these identifiers map not only to DBpedia, but they are related to Wikipedia pages. And so you can use these identifiers to access additional information in the DBpedia, a whole array of information, a whole web, if you like, which shows the benefits of linked data and this sort of approach. Mango has two components. There is a spotter and a disambiguator, and both are created using a complete dump of Wikipedia, which is available every month. They do a public dump. And the spotter basically has an index which matches surface forms found in the text to entities. So, for example, down here, you can see 4 surface forms which are related or could be related to Birmingham City Football Club. And they all map to this identifier down here at the bottom. But there's a problem. Of course, many of the surface forms are ambiguous. So Birmingham could refer to Birmingham City Football Club, but it could also refer to the city in the UK or the one in America or various other things. So we need a way to disambiguate those entities. So this is the schematic diagram for Mango, and you can see the spotter on the left, which is using the index derived from DBpedia. And it presents a set of candidate URIs for each surface form to the disambiguator. And the disambiguator uses something called word2vec. And if you've not come across this before, word2vec is a vector space representation of words. Now I'm showing it here in 2 dimensions, but it's typically 200 dimensions. And the key point here is that words which are related to each other and entities which are related to each other in this vector space will be close together. They will have similar vectors, whereas words which are unrelated will be a long distance apart. And you can do lots of interesting things with it. And the one thing we used it for was this disambiguation. So what we did was, you can create a vector to represent the document, basically by concatenating all the vectors for the individual words that you find in the document. And you can then compare that against the vectors for each of the candidate entities. So here I'm comparing the document with the entity representing Birmingham City Football Club. And the angle between those vectors gives you a strong indication of how closely they are related. The smaller the angle, the more similar that entity or more relevant it is to that document. And so basically we would put all the candidate entities through this and select the one with the highest similarity score. And this is a picture of Mango in action. So there's some text at the top. And you can see in the column on the left, the surface forms that it's identified using the spotter. And then the topic, which has been mapped to that surface form. And there's a score, which is basically obtained from that word2vec model, which gives you some indication of how relevant those entities are to the document. So Mango worked really well, surprisingly well, and was really useful in making the World Service Archive accessible. And it supported this prototype you can see on the left, which was run for a while. And it meant that the information which was completely inaccessible before could be easily browsed. And it means that people inside the BBC can search it and can find content. And there's actually now on the BBC website, you can look at clips and programs which have been found in the World Service Archive and relevant to contemporary issues. Now that's that project. And moving on to a second one, second topic, which is tag suggestion for news and sport. Now in the BBC journalists manually tag every published article when it's put through the content production system. And these tags are quite important because they might affect where a story might appear on the website, but they're used for various purposes, and they're very significant to how news manages its content. So it's really important the journalists do a consistent and thorough job of tagging each article. And they've been doing this now for about 7 years. But to help them, we've introduced automatic tag suggestion. And if you look on the right, this is a part of the content production system, they can either search for a tag in the category box at the top, but also there are these suggestions down below, which make it easier to find things. It's particularly useful if you've got staff who aren't very familiar with tagging, new staff, new journalists, and they're not familiar with how the BBC tags things and what topics and tags are available, because the suggestions will give them a good guide of how an article might be tagged. Now, we tried using Mango in this for a couple of years, I think it was, and it worked reasonably well, but there was a problem, and that was that there are typically 20 to 30 mentions tags for a typical news article. That's far too many to put forward suggestions, and it was very hard to identify which ones were the most relevant. So we developed a new text tagging system specifically for tagged suggestion in news and sport.